Hi, this is Roger from Kanka Labs, and I've got hold of another little gadget from eBay, this IC tester. We'll play around with it a little bit and later take it apart to see what's inside and try to find out how it works. It costs around 30 euros or dollar from eBay, and let's see if it's really useful. What, as always, or mostly always with Chinese gadgets, you don't get any manual or instructions. The only information you get is from the eBay site a probably with Google translated kind of description, and you have to find out yourself how you have to work with it. By the way, it operates from two AA batteries, so that's quite nice. It has a backlit display, and you have two modes to start it, either shortly pressing the enter push button, or if you press it for longer than 2 seconds, it will automatically check and find out which part you have inserted. Let's try out this auto check mode with a, let's see, with a CMOS 474HC4538. Let's insert it. It can test, as you can see, up to 20 pin standard DIP ICs, and it can not only test logic ICs but also transistors, diodes, LEDs, optocouplers, what else, SCRs or triacs, but we will concentrate on the testing of logic ICs and operational amplifiers. So it's relatively versatile, and let's try the auto function, and it displays 4538. Well, it cannot discern if it's a pure CMOS or an HC or HCT CMOS, but 4538 is correct, and that also gives you, well, perhaps not the guarantee, but you can be relatively sure that the IC is working properly. Now let's go and try to find out, and that really takes some time to find out how the menu works. You see, you have a two-line LCD here, which is even backlit. You probably cannot see this here on the camera, but I assure you it has a little backlight LED for even for working in the dark. Don't know if this makes so much sense, but anyway, nice feature. And to enter the menu, you see you have two fields here in the upper line of the LCD, and you switch between these two with the left and right buttons, and the up and down buttons are then the selecting. So let's see where we are. This is the main menu here, or the main menu item on the left side between off, which doesn't make any sense. Now here we can select amplifiers, which are what's meant is operational amplifiers. You even can specify the type. For example, here LM324. Which stands for a quad bipolar op amp. Let's see what else can we add. Now it starts really to get annoying to scroll through the menu. So you can check or test single op amps. The LM741 is only a placeholder for a bipolar single op amp. TL082, which means it somehow can discern between FET op amps and bipolar op amps, so that the TL082 is a standard dual FET op-amp, or with FET inputs and bipolar outputs. The TL084 is a placeholder for a quad FET input op-amp. It even can test the standard timer, the 555 or 555. And we have the LM2904. At the moment I don't know what kind of IC this is. 2902. The LM393 is a comparator. I think it's a dual one, and well, there are dual and quad types. I'm not sure. The 393 could be the dual one, and the 339 the quad ones. Have to look it up. The LM358 is standard for dual op-amps, so you have quite some selection, but basically this feature is unnecessary because you can simply insert any IC in the auto mode, and it will automatically identify it. So let's see what else have we got in the menu. We can test triacs, of course, only up to 5 volt gate voltage. So if your triac does not turn on with 5 volts, it of course cannot be tested. Zener diodes, of course, also only up to 5 volts Zener voltage. And some special other ICs like the ULN2803, a quad buffer. Again, it's a pain in the ass to change the menu items. 82C251, I don't know by memory what these are. I think this MC3487 is a serial converter, and so quite a lot of special function ICs. Even the MAX 485 and MAX 232 also serial to TTL converters. So, but of course, I don't know what light is. Is it for turning off the backlight, or is it for LEDs? Don't know. And then you can with the menu you can select a special single device. Here it's the CMOS series, the 45 series, and the 145 series. And if you go to the left side of the menu, you can input the number that you want to test. So I find this really unnecessary to walk through the menu. Let's see how to get back. Oh, it's really annoying, this menu where you don't see where are you on the left or on the right side. So that you see I can't get back to the main menu. Okay, then you can change the logic family to have HEF40, to standard CMOS CD40 series, and the 74LS and 74HC series. But as I told you, the best is, here they say siege, not search, but no problems at all if they've forgotten the R. Just let us check some ICs simply with the auto function or search function. But when it's on, you only have to press the enter button short, and we get the what we already had, the 4538. Let's try something else. What do I have here? Well, I just don't have to look it up. Let's see what the test result gives us. So, what will this be? An NE555. Of course, it will also not be able to discern between the CMOS version of the 555 and the bipolar version, but anyway, you have the function checked. What have we got here. That's what we already had. Now we have a LM324 standard quad bipolar op-amp test, and yes, LM324 or LM2902, which is pin compatible. And let's see, what else have we got? This must be a dual op-amp. I think I've taken out a LM358 and testing, yes, LM358 or the pin compatible LM2904. And what else do we have? We have a quad FET op-amp, a TL084, and it correctly identifies. It could have also been any other quad FET input op-amp. It will always display TL084 as a placeholder. And finally, another CMOS IC, a HEF 4029. And what do we get? 20, not 29, it was 27, so it's correct what it's displaying. So it basically does its job. In the days when logic ICs and op-amps were much more expensive than they are today, you really were hoarding all the ICs you could get, but it was quite difficult to identify faulty ICs and working ones. And this thing, for $30, it's a nice gadget. If you have some ICs lying around, either where the label is no longer readable, or where you're not 100% sure if they are broken or still working, or if your circuit doesn't work and perhaps has damaged your logic IC or your op-amp, you just quickly can test if the basic functionality of your IC is still okay. So they must have put some effort into the algorithm to identify and test the chips. And I don't know if this really is Chinese firmware or if this is also a open source project from anywhere else, like in the Fish 8840 component tester. So that was it for a basic check. Thing is working, except for the menu, which you don't need because of the auto function. We could still turn it off, insert any IC, and just to demonstrate it, if you press the enter button when it's off for 2 seconds or longer, it will automatically go into the search mode, and it immediately recognizes and finds the CMOS 4027. So everything all right, works nicely, and for $30 or euros, it's quite a nice addition to your lab test equipment. And now let's take a look inside how it's working. So on the back side we have the battery compartment with the 2 AA cells, where we also have 2 additional screws here, and let's unscrew them to see what's inside. And here it comes apart. So let's pull out the battery connection, and we have another 4 screws to unscrew, because apparently it's populated from the front side. Already a little botch. I don't think it's a resistor. It looks like an inductor, but that's no problem. So here it comes out. I'll just change the magnification so that we can take a closer look. So I've already disconnected the flat flex cable from the keypad. Now let's pull out the flat flex of the LCD. As you can see, the soldering here of the flat flex connector is not very accurate. It's not very straight here, but well, anyway. We see the main processor, an STC, what is it, 12C5A60S2. That's an 8051 compatible microcontroller from STC, a mid-range type. And we see a lot of identical ICs here. These must be octal buffers or latches. It are 74HC573, which are in my memory octal latches. We have all in all 1, 2, 3, 4, 5, 6, 7. 7 times 8 gives us 56 outputs. If we half that, we get 28, a maximum of 28 outputs, which either can be high or low. That's, I think, how they use it. And we have a 20-pin IC test socket. So this fits the numbers that you need for 20 pins to give them either a high or low or a tri-state. These octal latches can also go into tri-state mode, and so you need at least 40 outputs, and therefore, well, then 5 of them would suffice. So there must be some additional function. And we see 2 probably standard op amps. I can't read at the moment because it's 90-degree tilted. So let's see if these are LM325. No, this is also a TTL IC. It's an LS145, and this also looks like 145. So the magic happens all in the processor here in the microcontroller, and of course we have a little bit of a switch mode regulator, because from the 3 volts from the 2 AA batteries you need to generate either 5 volts or 3.3 volts. What I've forgotten is you can set the voltage, the test voltage, between 5 volt and 3.3 volt. But in my opinion, well, all the low voltage logic ICs, they are not available in DIP packages as far as I remember. You only get them in SMD packages. So to make use of the 3.3 voltage setting for logic ICs, you would have to have an adapter from DIP package to SMD. So this is a nice feature to test low voltage digital logic ICs, where 5 volts could destroy their inputs or the whole IC. So anyway, nicely built, except for the not very well soldered or not very straight sitting flat flex connector. Anyway, a nice little thing to have if you need one. And that was a quick look into into another eBay gadget, an IC tester for $30 from China. So if you liked it, give it a big thumbs up, and that was it for today. Thanks for watching. Until next time, bye from Roger, bye from Kanka Labs.